was in his physics department, and he has come as a guest speaker several times. I've seen his PDX TED Talk, and I don't know, just crossed paths many times, and he's a great speaker, so enjoy.
Thanks, Lynn. Let's see, I'm not muted, I think, right? People can hear me, and people can see my slides. Is that where 90% of the success of the evening at that point, right? Okay, so like Lynn said, let's see. So I teach physics and astronomy at Pacific University out in Forest Grove. At least for those of you in Oregon, I guess I should say, for those of you who are in Thailand or, or wherever. So what I mostly want to talk about, and of course this is kind of open-ended and we can take a conversation wherever you guys want to talk about, but what I had in mind to share is what I've been thinking about recently is this kind of, I guess I would say, an exploration of the experiential side of science, and specifically astronomy. But so really kind of the subjective impact that it has on the frame of mind of the people who participate in it. And I put the word, I added the word inclusive to the title with the idea that the people who participate don't have to be officially practicing scientists or whatever. They can be people who ride by on their skateboards and say, cool, there's a telescope, can I look? Just sort of trying to get people into that actual frame of mind where they feel like they're part of the universe and are not just focused on the data that we're collecting, although of course that's important too, but really trying to emphasize the highlighting kind of the inspiration that we experience when we're out under the night sky, sort of having a conversation with a star, which is kind of what I think of as doing astronomy, is kind of like that. Anyway, so I'm trying to, the overall perspective, I guess, that I have here is to describe some projects that are ongoing that try to put this into action, this idea of how do we do science in a way that brings us back into awareness that it actually changes us to be in the process of doing it, right? Not just what results we get, but what do we experience? How do we feel connected? That sort of thing. And I put this up here because the inspiration for the title, or the subtitle anyway, it came from this book that I came across a few years ago by Henry Bortoft, who's a kind of philosopher of science. That's called The Wholeness of Nature, Goethe's Way Toward a Science of Conscious Participation in Nature. So that's kind of the, finding this book was kind of a crystallization, I guess you could say, of a lot of my journey that kind of brought to a focus kind of what I was trying to get at. So I'll come back to this book a little bit later on, but so I thought before I get into the specifics of projects, I thought it would be useful, especially in this group, to kind of talk about essentially my wanderings, right? Sort of, the background, the kind of, I guess just sort of the background. I'll go ahead and jump to this, of what my path has been. And I really resonate with that Mandelbrot quote that, that you have as the kind of guiding theme of the organization, that idea of being wanderers by choice. And also the idea, I guess, that when you are sort of guided, when you make decisions guided by an internal compass about something that you're sort of looking for and trying to figure out, it can look like wandering relative to the structure of society and the structure of, kind of career paths and things like that. But it really, I think, has a very clear internal purpose sometimes. So I'm hoping maybe it'll be interesting to see an example of my path. So I put up here sort of the guiding theme of my wanderings is this phrase that I refer to a lot, is looking for meaning in the modern universe. And going back to like even high school, probably even middle school, when I think about kind of the things that have driven me and why I've gone into the career things that I've gone into and the questions that I've researched and stuff, it's really been this kind of, I guess you could call it a tension between a recognition of the profound value of science, right? I mean, the scientific process to me is just feels very, very important, and I don't want to kind of go too far from that. And yet, so the tension side of this is that, so that's why I became a scientist and all of that. But I've always had this kind of uneasiness that maybe some of you share with what might be called the reductionist narrative that kind of goes along with the scientific culture and still I think kind of dominates scientific culture. And so I guess I would say that my journey has centered around trying to understand that tension and ultimately trying to create a narrative that I'm comfortable with, kind of, in a way, right? I mean, sort of a narrative that resonates with all aspects of my being, both being intellectually honest and true to the scientific evidence, but also kind of spiritually and emotionally satisfying. So, kind of like Don, we were talking about at the beginning about the Stephen Hawking's comment about, God being found, where is God, sort of found in nature. Okay, so just kind of very briefly here, that journey led me what looks like kind of all over the place. I did astronomy research as a middle school and high school student. I'll come back to that a little bit, but I knew that somehow I watched Carl Sagan growing up, and whatever it was he was doing, that's what I want to do. If you remember, those of you who saw the original Cosmos, if you remember this scene in the opening episode where he takes the dandelion seed and lets it go and says, "Come with me," and sort of out into the journey into the universe. And I think I was about 9 when that came out. So, I will definitely come with you and follow in that journey. And so that kind of guided my sense of what it was going to be to go into astrophysics was that, his story, that kind of sense of figuring out where we came from, what it all means, how music and art and poetry and science all fit together into our history and all that sort of stuff. So I was told that the thing you do if you want to go into astronomy is you major in physics. You take lots of physics and math in high school and you major in physics. So I went to University of Illinois for undergrad in physics. And I also took lots of classes in philosophy of mind and philosophy of science and religion and things like that. So I was sort of exploring the path then. And I even considered fairly seriously going to grad school in philosophy. I had some good philosophy of science professors that kind of guided me as an undergrad. I ended up taking, some of you probably know who John Wheeler is, the guy who coined the term black holes. And I was really inspired by a lot of his writing. And so when I was trying to decide what to do, I actually wrote him a letter that surprisingly he wrote back, a nice handwritten letter. And one of his pieces of advice that I ended up taking was, he said philosophy was too important to be left to the philosophers. So, which I was a little bit offended by, since I was considering becoming a philosopher. But I think what he meant by it is that you really need to understand the science deeply in order to do the kind of philosophy that I was interested in. So, so that led me to, I went to grad school at Cambridge, and then did my PhD. So I did a master's degree at Cambridge and did a PhD at University of Chicago, and got to study with some really interesting people. Martin Rees was kind of who motivated me to go to Cambridge to study cosmology. Angela Linto and Mike Turner were some of the people at Chicago that focused on cosmology. I did, coming back to our starting conversation, I did get to sit in on some seminars with Stephen Hawking, which was really fun to just kind of see, what that world was like, right? What they focused on, what kinds of questions were being asked and things like that. But interestingly, I found that as I got farther and farther along, I got kind of more and more disenchanted with what specializing in science, I guess you could say, was. I was sort of expecting to get closer and closer to these deep insights into things, and what I found for the most part, which again is still a very useful thing, it just wasn't for me, was that it just became more and more specialized, and I felt more and more like I was kind of filling in the map on some detailed question, and it somehow wasn't touching the questions I was really interested in. And I had really supportive professors in grad school that kind of helped me, figure out where to go with that. I ended up doing my PhD kind of in history of science, I guess you could almost call it. I was interested in the origins of our ideas about the second law of thermodynamics and the arrow of time. And Ludwig Boltzmann had a lot to say about that. So I ended up kind of analyzing some historical things about how Boltzmann kind of derived, in a sense, the second law of thermodynamics from microscopic principles, and what went into that and what kind of assumptions were involved in that. And I guess the picture I sort of want to paint is this idea of, having this clear internal kind of idea about there's something here that isn't fitting together right for me in terms of a picture of how the world works and how we and our ability to be conscious and, think about all this fit in, and with what I knew about the laws of physics and what the picture was I was getting from that side of things. And I'm sort of trying to figure out where the gaps are, how to make a narrative that's consistent, I guess, is sort of what's going on in the back of my mind. And then I'm trying to pick projects that fit with that. And so now, a couple of decades, or 3 decades, I guess, almost now, further along, when I look back at it, what I was working on with that project was trying to understand what I would now call the incompleteness of dynamical laws. So those of you who are interested in mathematics and have studied like Gödel's theorem, the incompleteness theorems and things like that are sort of related to that, if you're familiar with those. But basically the idea that we can have laws of physics that tell us what's going to happen, but only to the extent that we can pin down certain parameters to describe the world. And there's some paradoxes that come up in that. There's some holes in the description, and one of them comes up through understanding how is it that the second law of thermodynamics, which is a very one-directional law, right? There's a direction of time that has to do with how entropy increases, and yet it seems to be derivable from microscopic laws that don't have that arrow built in, right? That are symmetrical with respect to time. And so that was kind of my first foray into trying to understand that. And then that kind of got put aside, and I, was trying to figure out what I wanted to do career-wise. And that's actually what brought me to Portland, is I knew I wanted to do something interdisciplinary. And there was, at Portland State, there was a Center for Science Education that was an interdisciplinary kind of science program. And that appealed to kind of what I was looking for. So that's what brought me from Midwest out to Oregon. Pretty much the only thing I knew about Oregon was that Nike, I like to run. So I had shoes that were made in this mysterious place called Beaverton, Oregon, that ended up being home for a while. So anyway, so then I came to Portland, got involved mostly with teaching then, and trying to bring these sort of perspectives into how we educate students who are not scientists into understanding what science is all about and how it's relevant to their lives. And so, that was kind of another piece of this big puzzle. And then in the process of doing that, again, trying to figure out the kind of philosophical underpinnings of all this, I started a little nonprofit called the Science Integration Institute has similar goals, I think, to the Wanderers Group. It's sort of a place for people to talk about how science connects to other aspects of life and sort out some of these questions. As life goes, I sort of ended up spending a lot of time on just the details of teaching and how to get classes running and keeping up with students and things like that. But always kind of in the back of my mind, I'm still spinning on these questions and going to conferences and occasionally writing papers on these things and, making little bits of progress and finding connections with people. And then, so I guess, again, I'm trying to paint this picture of following this journey through trying to understand, okay, how does consciousness relate to foundations of quantum mechanics and relate to arrow of time, and just piecing it all together. And then I ended up moving to Pacific because a liberal arts college environment had always kind of appealed to me as a place to have this interdisciplinary kind of conversation. And there was a visiting position that opened up that I got a chance to sample it for a little while. And then about 5 years ago is when a permanent position opened up. So, and I had colleagues in kind of a network here. And so, that ended up becoming home. And now I'm still wandering in many ways, but, now I feel like I'm kind of settled here, and this is kind of the place where I'm going to solidify things. And about that same time is where I kind of felt like, at least in my own mind, a lot of these pieces about how I can see a way of looking at science that leaves room for the kind of meaning that I'm looking for, kind of gelled. And that's what those of you who watched the little TEDx talk, that kind of gelled into that. That's where I feel like, okay, now I sort of understand how I'm viewing all this. Okay, so that's all sort of background. And then the other side of all of this philosophical thinking going on is how to put these kind of things in action. So like that TED Talk is a little bit in that direction, but something that seems kind of unrelated. Let's see, I think I'm gonna skip to this. Is just how to implement this, right? So, there's always this sort of philosophy of how we're thinking about things and what your sort of worldview is. And then there's how it gets implemented in terms of making a difference with things. And this, the way a lot of these things happen, it just kind of pieced together from, as a kid, I did variable star astronomy observations, like looking at stars that change brightness as a kind of a concrete thing that I could do to be involved in astronomy research. And then when I came back to Pacific a few years ago, one of the things we really emphasize is doing research with students. And so trying to have projects that the students can be involved in. And so I had some students who really resonated with the idea of, they wanted to be out at the telescope, they wanted to do observations. I've been involved a lot in doing public outreach for astronomy kinds of things anyway. And so it just, through the personalities of some of the students that I was working with and the things I was interested in, we ended up having this kind of idea that it would be interesting to combine these two things. So public star parties, but at least from my perspective, a lot of the reason that they're interesting and fun and people flock to them is that they create this really powerful experience of connecting both to the cosmos as a whole and connecting to our fellow humans, right? And kind of both seeing the big picture and seeing how much we have in common, right? So it's just amazing. So let me just show a couple of pictures here just to kind of, hopefully, not that I can do justice to the feeling, but to give you at least a little bit of the feeling of what it's like to be out at these kind of things. So this is one that we do up at Mount Hood, normally every summer. I don't know whether they're going to happen this summer or not, but hopefully. This was at a park nearby. This is more Mount Hood. And then we started doing them just right on campus. So this was an advertisement that my students put together, just sidewalk chalk, that there's kind of a thoroughfare on campus where we set up and people literally will be out walking their dogs or riding by on skateboards or whatever at night. And we end up just having these spontaneous classes almost, right? Because people are curious, right? They see a telescope they want to look through, they see the rings of Saturn, or they see a distant galaxy or whatever. And then all these questions start unfolding from there, right? And not just questions about astronomy, but just questions about, you get to meet other people regardless of your politics or whatever, right? You get to just chat with people in a context where you're really tangibly reminded of the fact that we live on this little blue dot and what we argue about is maybe not such a big deal, and maybe we can find some common ground. And so it's a pretty powerful experience, I find, just listening to, especially at these ones at Mount Hood. We start when it's almost dark most times, although this one obviously it wasn't. But so there'll be people there that you never see their faces, right? You just hear their voices and you have no idea who they are, where they've come from. Again, especially at Timberline, people are there from all over the world who just happen to be staying at the lodge. So it's pretty amazing. Sometimes when I can sneak away from the questions, I go just like lie down, behind a car or something where I'm kind of out of the way and won't get stepped on, and look up at the Milky Way and just listen to the conversations that people have, that from really silly mundane things to really deep philosophical conversations to political discussions and whatnot. And it sort of feels like, as you're looking at the stars and listening to the conversations, you can almost get a tangible sense of like remembering that we are the universe talking, right? Those conversations you hear are literally sounds of the universe, right? We're part of all that. So anyway, so just to have that kind of sense of that space, and that's a really powerful kind of connection. But then there's another different kind of connection that happens when you're doing the sort of narrow focused research, like when you're, to make it really concrete, one of the things I'm interested in is exoplanet detections. You can basically, it's kind of like an eclipse. If you happen to be lined up right, so like if here's the star and here's a planet going between your line of sight and the star, it's not nearly that dramatic a size comparison. Usually, it's much smaller in comparison, of course. But if you have a sensitive enough measurement, you can detect the fact that the light from the star dips a little bit when the planet passes in front of it, like a mini eclipse. And that's one of the main ways that we detect planets around a lot of you probably know there are over 3,000 known exoplanets now. In fact, we know that statistically, probably 50% or so of the stars you see in the night sky probably have planets around them. So a very concrete research task can be to set up a telescope, have a light meter that detects the brightness of a particular star, and you can measure the brightness of the star over time, and you can detect if there are these little transits happening. And I guess what I want to juxtapose here with the combination is that there's something really powerful that happens by being engaged in that process, right? That you're very focused on that one star, but it makes you think about, oh, that's like one of the ones we're studying is about 70 light years away. So you can think about a friend of mine who's 75 now years old, the light we're looking at now came from around the time I was born, right? And there's something real about internalizing that knowledge while you're doing it, while you're actually looking at the star. And so basically the idea that my students and I have kind of started implementing is combining the two. And there's many ways to do this. Let me show a picture of actually on campus here where you can kind of see what our setup is. So in this kind of major thoroughfare walkway that goes through campus, most people doing research would think this is a really bad idea in a lot of ways, that, we set up in a not very dark spot where there's lots of people coming by to actually do our research, with the idea that then we've got enough people involved and a couple of telescopes usually, so that then people can stop by and ask what we're doing, and we can get them involved, right? So that they can participate and they can actually, and there's some very simple ways with variable stars. You can actually see a lot of stars change brightness just with your unaided eye. And there's a great organization called the American Association of Variable Star Observers, in case you didn't think there were enough specialized organizations out there in the world, that has a great website and finder charts so that you can find the stars, so we can hand these out to people. And they can actually, within minutes of seeing us doing our research that might feel very inaccessible in a lot of ways, right? You're used to reading about in the news and thinking astronomers on some mountaintop somewhere are discovering these things. It can be brought down to, literally you're out walking your dog before bed and you can join in, right? And sort of be part of that research. And again, part of that frame of mind that creates. So that's kind of the spirit of what we're up to, what we're doing. We're kind of just building up the details of the project, and it of course kind of got detoured a little bit by COVID, and we've had to adapt to doing some things virtually and preparing for when we can have big crowds again. But Yeah, so let me just, unless there are, I guess I probably already said, but to interrupt any time with questions, unless there are questions so far, I'm going to kind of give you one specific example of something that one of my students is doing. Go ahead. I hear.
So Todd, what kind
Yeah.
of telescopes are you using?
Good question. So, so part of our point here, so the one you see in the picture here with me, with Justin, who's one of my students, this is just a standard Meade 8-inch Schmidt Cassegrain telescope.
Just an 8-inch.
Just an 8-inch. Yep. Yep.
Okay.
And you'll if you're impressed by doing this with just an 8-inch, you'll be even more impressed in a second when I tell you about the 4.5-inch or 5-inch in a second. But so part of the goal of this, and I don't know how well you can see this picture. This one's a little bit better. I mean, it sort of became a joke that we sort of talked about, our MacGyver approach to doing this research, but in a way, it became part of the point, was to sort of show people that you don't necessarily need super sophisticated, fancy. I mean, it's a little bit expensive, but you don't need the top of the line equipment to do some of this. So we have an old photometer that it's not even. You can do a lot more with a CCD camera. But this is literally just basically like a light meter. It's almost like a single pixel, like a solar cell kind of thing that just really precisely detects light, that we just had in a storeroom in campus. These things have been made since like probably the, gosh, I don't know, 1980s, I think at least. And they're really simple to use. So it really is just basically like a light meter, and you jump from one star to the next and you compare the brightness and write down the readings that you get. And we, in order to counterbalance this, you can probably see these are like ankle weights that we've made use of to do our, with an inner tube and some duct tape and all that sort of stuff. So again, it's supposed to sort of show people that you can do this with everyday kind of stuff. Although I suppose most people would not think that even an 8-inch telescope is not necessarily an everyday thing, but still kind of. And we're doing this right on campus, with the idea being that then people, I mean, I actually literally have had somebody cruising by on a skateboard and you could see his head turn. I was glad that he didn't crash into anything on that. You could see his head turn as he was sort of watching what we were doing. And then he hopped off the skateboard and came over, and, the literal quote was, "Dude, is that a telescope? Can I look?" And, that became a long conversation, right, with somebody that got involved in what we were doing. So anyway, so the specific thing that we are trying to build up to is we're looking, there's one particular star that's a pretty easy to detect exoplanet. It's got the very boring name HD 189733 is the star. So HD 189733b is the planet around it. But so I've got just a photo that we took. So this is M27, which is the Dumbbell Nebula, which is a really pretty common thing to look at for amateur astronomers. So it happens to be in the same field of view, so it makes it pretty easy to find. And this is just a finder chart for it. And so what we actually do to make these measurements is this turns out to be a good comparison star for reference, so that we can tell, you have to sort of subtract out any effects from the atmosphere, right? Because the star brightness is going to change dramatically just due to fluctuations in the atmosphere. But if you have another star going through roughly the same atmosphere, then you can subtract out the effects due to that. And then you're also getting light just due to the brightness of the sky, especially from where we are. And so you find a region where there's not too many stars, that at least they're very faint, and you can subtract that out in order to get the brightness measurements that you need. But that's the region of sky that we look at, and we literally take a reading for a few, like 10 seconds on this, and then a reading for similar length of time on this, and then we take a sky reading to have a background to subtract out. And then the data analysis is pretty straightforward, that you can just do it in a spreadsheet to essentially compare over time, what's the ratio of the brightness of this to the brightness of this. And if you do it at the right times, here's a preliminary kind of graph that we got, that this was an already known transiting exoplanet, so that the transit being the eclipse sort of thing. This was the time when it was predicted that the transit would happen, and the brightness ratio was roughly constant before that happened. And then around the time of the predicted dip, you can see it dips down, and our goal was to actually see it go back up another hour or so later. But living in Oregon has its pros and cons. One of the cons is clouds. Clouds came in and interfered with our ability to get the rest of it. But it's interesting. So it kind of going back to my original theme here, that, you know, I've looked at thousands of these graphs that are taken by like the Kepler satellite and things like that. So it's not like I've not experienced, in some sense, the knowledge that these things happen. But I can tell you, this is like probably one of the most exciting things I ever experienced in my life. Was actually, you know, this is the first time, this was last summer. This was the first time that I was out at the telescope, you know, looking at a star, writing down numbers that, you know, there's something about the experience that's transformative, at least for me, about that, about knowing that I saw that planet go in front of that star after it had been traveling for 70 some years to get to me, and, you know, picturing the ripples of light that are coming out and sending that information. And there's something really powerful about that experience, I guess. So our next step, this was sort of a trial to see if this was even possible to do this. Our next step is, for this coming summer, what we want to actually do is try to organize where we have a star party organized at a time when one of these trees, so kind of like an eclipse viewing, you know, sort of feeling, right? Where we have a star party at the time when one of these transits is happening. We'd have some telescopes set up so that people could just view the field of view to see where the star is, and then also have someone collecting the data and graphing it in real time, so that you can actually have the anticipation of, you know, watching these data points come in and projecting them on a screen, on a projector, so that the people that are gathered there can actually, you know, probably not quite as cool as watching the eclipse and seeing the sun go out, but still, you know, you have this anticipation of, okay, they're staying constant. When's it going to start dipping? Are we seeing it? You know, that sort of experience. So that's the goal, is to try to create something like that we can kind of weave into a star party. And then back to the question that someone asked a minute ago about the telescope. So there's a new telescope that we're trying to weave into this project. There's a company called Unistellar, that's a startup company, just UNI and then Stellar, that has created this little portable scope that it weighs about 12 pounds, I think, something like that. It's just like 5 inches across, and, you know, this long, something like that. And it has an integrated camera and computer in it, so that the idea is, and everyone's linked together in a way that you run it from an app, so that the SETI Institute scientists can actually suggest objects to work on, to, you know, target objects to make observations of, and people all over the world can join in to make observations, and they get automatically sent to the kind of database that they're keeping of this, and they're doing a good job of kind of keeping a website, keeping everybody informed. So, you know, we're going to try to connect up with that, and part of the idea is to create this sort of network of people both gathering data that's useful for research on exoplanets, or there's a planetary defense one looking for asteroids that might have Earth crossing orbits that might be a concern. Again, with that spirit of not just having people know the facts that are being learned, but making it easy for people to have the experience of participating in it, right? So that you are aware that you're part of it, you share that experience with other people. Anyway, so that's kind of the gist of the project that we're doing. And I wanted to just briefly return to part of why I was so excited about this, discovering this book by Wartoft about Goethe's approach to science, is that, you know, this was new to me to find this, right? This is one of these fun things about, you know, finding the history of how ideas have been created and how science goes a particular branch, and other things get kind of left behind, but they're still there and you can rediscover them as you go along. So Goethe's whole approach to science was very much about doing science in a way that kind of, rather than standing outside of the phenomenon and trying to model it and kind of explain it by replacing it with some other model, which is kind of what we tend to do a lot of the kind of, I don't know how you look at the scientific process, is building a model to try to explain something in terms of the model. His approach to science was focused on the translation is dwelling within the phenomenon rather than standing outside of it. So trying to sort of experience get a full sense of like what's actually happening, which I'm kind of thinking of in terms of the astronomy as being like the difference between just looking at the numbers for the brightness of the star versus being out there under the night sky, thinking about the path that the light took, you know, thinking about how old you were when the journey left, or, you know, when the light left on its journey, and all that kind of thing. So, you know, I'm intrigued, and I'm still in the early stages of kind of thinking about how to do this with students, but just trying to make it so that even the data collection process we go through leaves space for us to think about those things, right? Even not just asking about what's the brightness reading that we got at that point, but having even space in our data sheet to write in comments about thoughts that you have about the connections and things like that. Okay, so that's probably, there's other things I could say about all of that, of course, but that's probably a reasonable thought to kind of stop and fully open it up to just whatever people want to discuss.
Yeah, very interesting approach. Astronomy is a little tough for me to contemplate, but you seem to have done a great job. But it's the way I learn about sciences that I wasn't formally trained in. So I need to learn about geology. And so I collect gemstones and have a little laboratory so I can look at them. And I garden so I can collect plants and learn how they grow by observation on my own. And there's a huge difference between reading about it in a book and actually seeing it on your own, even though I don't do it in a group setting, although I turn around and give talks to this group about it.
Mm-hmm. Mm-hmm. That's a very good point. Right, exactly. There's that sense of like something happens and I guess, I mean, in a sense, maybe that's, if I was going to have one point of what I'm trying to figure out how to explore more, it's just reminding ourselves that there's something real that happens in that process, right? It's not just the objective, like, okay, here's the chemical formula for this. There's actually something going on in my mind that when I feel that sense of awe, or, you know, like you're experiencing with gardening, or with, you know, knowing the history of these rocks or whatever, right? Yep.
Exactly. Yeah.
So when I was walking Pacific Campus, as I often did actually last night, and a couple of years ago, it was pre-COVID, came across you with several students, and you were listing out numbers.
Yep, you were witnessing exactly what I just talked about. Those numbers were the brightnesses of stars. Yep.
Yep, that's very cool. I
Yeah.
always wanted, for some reason I didn't ask, but I was kind of wondering what you were doing out there.
Next time you're out, we were actually out last night again too. So I'm surprised we probably just barely almost crossed paths. But yeah, absolutely. Just if you hear numbers being called out on the Pacific Campus in the middle of the night again, stop by. And that just brings up, I mean, there's something really fun, even just like the security guards, that patrol campus now all know about our little experiments, and they'll stop by to see what we're looking at, and they all know to turn off their lights on their little golf carts when they come by, our direction. So again, it's, there's this sort of very intangible in a way, but just this sort of vague sense of how just being there in public doing your research kind of percolates out into how people think about astronomy and what they're aware of and stuff like that, which I think is kind of cool.
So do you do this kind of thing in physics as well? I mean, you've got your physics labs where your students get hands-on, but have you thought about ways to do this for the general public and physics principles?
That's a very good question. I have thought about it only in the sense that, other colleagues have asked basically that same question that you just asked. And so, it's sort of floating out there of like, how could we do this sort of thing with other subjects? And we have not done anything very extensive yet, but you're totally right that we could. And I would definitely be interested in ideas you have if you.
Yeah, well, for example, mechanics and the principles of mechanics, whether you start with a teeter-totter or whatever,
right?
To talk about levers. I mean, there are lots of easy ways to do that.
Yep.
And like when I was teaching introductory chemistry, one of the things that I had my students do was grow crystals as an understanding of one, crystal growth, but also looking at shapes and all of the other things associated with changes in concentration of ingredients and all of those kinds of things. And those were hands-on, and they could do that in a group and argue about what to change in order to make it grow better or worse or however.
Right. And
so there are lots of ways you can do those kinds of things.
Yeah,
I just had never thought about the fact that you could actually do it in astronomy.
Gotcha. Yeah. Yeah, and I like the crystals also because then they can go home and do it in the kitchen or whatever. They can look for other places.
Well, that was the whole point.
Yeah.
Here's the stuff like crema tartar. Basically, you can take that home and you're not going to kill anyone.
Right. Hopefully.
Yeah. So you can grow tartrate crystals with no trouble at all.
Uh-huh.
And those you can do and should do in your kitchen.
Right.
I had a student that had access to the solar telescope that Rose City astronomers had, and he took it across country and stopped in any place in the daytime, and had people gather around just on a corner and tell them what they were seeing when they looked at the sun. And it was just, he had people inviting him to stay overnight with them and stuff like that. It was just, he really played it. He had a really good voice, and he could just, it was a very, like,
good performance kind of thing or whatever.
Like Doug McCarty kind of thing. As a matter of fact, he's a friend of Doug's.
Yeah. Yeah, cool.
So could you do this with something like one of the old Celestrons?
Yeah. And so in fact, I mean, I guess getting more into the details, like the surprisingly, if you were willing to go a little more sophisticated in terms of the data analysis, you could use a very small telescope with a CCD camera, and you can do the photometry, the brightness measurement comparison. Like even so, this little portable 5-inch telescope, they've done detections of exoplanets for stars down to like, I don't know, I think it's probably like 11th or 12th magnitude. So they're relatively faint stars. There's a lot of possibilities for stars that are accessible that have exoplanet transits. That definitely with like a C8, you could easily set up a detector to be able to do this kind of stuff.
And what other sorts of phenomena might you be able to do similar things with?
Yeah, so the things that are kind of part of this network right now, The main ones are, so the exoplanet transits, and then there's a, they're calling it planetary defense, which definitely gets people's attention, right? You want to be able to say, I'm on the planetary defense team. And basically what they do is they take images over a sequence of time of asteroids, and you can do brightness measurements again, and once you have the pictures, you can analyze them after the fact, and they can do plots of brightness over time as the asteroid spins, and you can get like the rotation rate, and the you can basically build models if you get enough observations from different people in different perspectives of the actual structure of the asteroid, and again, that becomes useful because it can tell you things about either well, if we ever wanted to mine asteroids, you can find properties, that way you can get an estimate of like what the composition is and stuff like that. But also if we ever needed to nudge one that was on a unfortunate path, the collision course with the Earth, knowing that kind of stuff could tell us things that we need to about exactly what its trajectory will be when it interacts with the sun and things like that. So that's one that a lot of people have gotten involved in, and they've gotten, good scientific results that have actually told them new things about some of these asteroids. A related thing for trying to really refine, in fact, we just did one with, you may have heard about Apophis, which is the asteroid that they spotted back, gosh, I don't know how long ago it was at least 10 years ago, maybe 15, that it made a stir when it was first discovered, because for a little while there was a reasonable, like more than 1% chance that it was actually going to hit Earth. I think it was on Friday, April 13th, 2029, if I'm remembering that. I know it was a Friday the 13th, of course. And so they're trying to, now the odds are, they've refined the orbit and it's not very much chance at all that it's going to hit Earth, but still people are trying to refine the orbit as precisely as they can. And so what they have people do is, if you are in just the right spot, an asteroid will block out a star. It's called an occultation, and it's very sensitive. Whether it actually occults the star or not is very sensitive to your exact location on Earth, and so you can get really precise position determinations of the asteroid at that moment, and that lets you predict its trajectory really accurately. So that if you're trying to anticipate, like, is it going to hit Earth or not, you can figure that out. So that's one that a lot of people have been involved in too, because it requires people being spread out in many different locations, because you don't know exactly where you're going to be able to see it. And it's pretty easy to do with even a small telescope and a camera. Yeah, so I'm excited about the possibilities for this this unistellar EV scope, specifically because of the fact that it's going to put this capability in the hands of lots of people. So it'll be interesting to see what comes out of that. So those are the three projects that I know of. I'm sure there are other things that people come up with that can be done with this. But
I'm David Thompson.
Hi, David.
I loved physics in high school, and I did it in college, but I ruined the whole direction in that direction by going into medical school and pre-med. It was like I had to do physics and I had to do this and that and the other. Anyway, fast forward, I was in internal medicine, and when I was about 40 in the early 80s, I got really interested in toxicology. And I had a lot of chemistry, and so I went to UCSF where they had discovered they had a 6-week program in occupational medicine, it was called, but at UCSF, and it was 3 2-week segments. And I had an uncle, Erwin Hahn, who was a physics professor at Berkeley. Okay. And so I called him, and he said, "Oh, come and stay with us." And so I would get up at 5:30 and go over the bridge and do this. And the second time I came, somehow he learned that I played the flute, and he said, "Oh, we'll do the Mozart." And it turns out he had a string quartet that came over to his house, and every now and then, and they were all physicists. And so I brought my flute, and it just totally destroyed my reputation as a musician. But I loved playing with those guys. And so we took a break, and my uncle he died at 97 a couple of years ago. And by the way, he went to University of Illinois, and in 1954 he discovered the proton spin echo effect, and got pretty close to the Nobel, but didn't get it.
Very cool. Huh?
Died too early. Anyway, during the break, he started having this conversation with one of his colleagues in the department who was an astrophysicist, and he was a black hole guy. And my uncle was a small particle physics guy who did experiments at very, very low temperatures. And they got into this most animated conversation. And it was like, oh my God, I'm in the center of knowledge, because these two guys were talking about the tiniest things and the most huge things in the universe. And I was there hearing it. I didn't understand what they were talking about, but I got the idea that science being what God is all about. I think I met Edward Teller when I was in college, and he had it backwards. I think he was the devil who believed in science. He was the hydrogen bomb guy.
Right. Yeah.
And anyway, it was a wonderful memory, and I wish I had the name of that astrophysicist that he was engaged with during the entire break, because it was just unbelievable to see that. And I'm hearing your talk all about telescopes and looking at the sky, and I just keep thinking about we were in that conversation. They were all the way down to the most tiny parts of the universe, and they were talking about the same principles.
Yes. Yeah, that's really, one of the most fascinating things to me about cosmology is that it's made up of this mixture of people that like thinking about the really big things, combined with people. I mean, they're actually like Mike Turner is one of my professors. He started out as a particle physicist, and he basically went into cosmology because he figured out that he could actually study. He could study tiny things. The universe provided a particle accelerator that we couldn't afford. Right. So it's really cool that it all loops around and it's all connected.
It's interesting because I look at the cosmos from the point of view of chemistry, and I've given a number of talks to this group, but looking at isotope ratios as a way to learn all sorts of things, from the origin of meteorites to the origin of comets, and you name it, but all of it associated initially with my chemistry background and the idea of looking at how isotopic ratios of things like oxygen or nitrogen or a lot of other esoteric things can give you information about the origin of the planets, and like I said, of everything from asteroids to comets and galaxies and so forth.
When James Burke was at ICEP talk, he was telling about how he pitched his idea for the connection series of the history of technology with the BBC, and he had heard that you should be able to give your pitch with one sentence. And so he had seen from another guy that he said that everything is connected to everything. And he called this guy up to say, I wanted to do something that you said. And he says, hell, I got it from somebody else, And so he used it, and he got 10 1-hour shows and an extremely good, series that he did on that, and the day the universe changed, and all those that were really powerful in my life, to me.
Yeah, that was another great series. You know, I was thinking about as soon as you said James Burke, I was thinking Cosmos and Connections were like my two favorite things to watch. Yeah.
Yeah, well,
I love that show too. It was, and I was so pleased that he came to speak in Portland because he's like a hero.
A few times, actually.
yeah. Well, one of the things we've been talking about is the whole idea that you initially brought up, Todd, and that's interdisciplinary thinking, whether it's physics and astronomy or whether it's you name it. I mean, I've always worked at the interface between different areas of science because I get bored being in just one. And I don't like that idea of drilling down, looking for the little details. I like to step back and think about problems that you can only solve from an interdisciplinary approach, whether that's in pure science or in management or other aspects of business for that matter. How do you approach trying to teach your students to think in an interdisciplinary way?
Sorry. Yeah, that's a very good question. So I'll start. I mean, so one example, the example that's fresh in my mind right now, because I'm immersed in it, is so I have. I teach the intro physics is kind of most of my teaching this semester. So I have 99, in fact, students in this intro physics class, or 2 intro physics classes, and almost all of them have an interest in some sort of health professions. So a lot of them are biology majors, but you know they're going into physical therapy or pharmacy or medicine or things like that. And so one example that's on my mind right now that I found has worked really well is I've stopped using regular exams. So they have homework and they have to learn how to do problem solving and learn all the basic, Newton's laws of motion and all that kind of stuff, for law of gravity and stuff like that. We're on electricity now. But what I've started doing, that was a little scared about it first because it's so open-ended, but it's turned out to work really, really well for the students to do this kind of interdisciplinary thinking, is that their exams are all formulated as, I give them an example first, but they have to find a problem in their lives that something we've been talking about is related to, and then they have to come up with a question, like they have to turn it into like a homework problem and then give the solution, right? And so of course they sort of freak out about this at first. It seems very open-ended and just give me a problem to solve, right?
Well, it's not rote memory that you're
asking. It's not rote memory. It's not,
forbid.
Which equation do I look up and how do I do this? And so, so part of the reason I've been, their most recent exam was just due about 2 hours ago. So last night, was filled, yesterday evening was filled with conversations with students, which was wonderful for me too, because they come up with, well, I'm interested in E-stem machines that stimulate your muscle. And so there's just all these random things. Somebody was literally trying to wire their house and they were trying to solve a problem about how to, but the thing that's interesting, and I do give I think this is the key, is I give my own interdisciplinary example, right? So like I give an example where like I was cooking some frozen vegetables and I set up like, you have to give background about what the problem is. And here's kind of an example of how to do that. And then you have to use equations and you have to sort of explain how those equations fit together and stuff. But once they get into it, you're forced to come back to your question, they're forced to do something interdisciplinary because their lives are interdisciplinary. So it kind of forces them to make that happen. But I guess so my one sentence version of of how this works well, I think, is make the students pick a problem of interest to them,
Yeah.
and then filter
Perfect.
what they've learned in order to solve that problem. Because then it makes them, yeah. So the sidebar here is what I worried about is that maybe they wouldn't learn all the important concepts and stuff. But what because I'm not giving them an exam that's going to cover everything. They can choose to focus it. But for most of them, what's happened is that they end up having to pore over all their notes to figure out what the heck am I going to do for a problem. And so then they learn all the basic ideas, but with the lens of what am I interested in, is how does it connect to back to the James Burke, it forces them to make connections rather than just
I mean,
yeah,
very understandable for the non-science major students in chemistry that I spoke with. The connection, interdisciplinary connection that I made was between chemistry and cooking.
Yep, good.
All of the food science associated with the chemistry of cooking, and every time you do anything from fry an egg to use baking soda to rise a cake or something like that, there's chemistry involved, and figuring out where the chemistry is and being able, as you said, to write equations or something like that is the same kind of approach, not quite as sophisticated as yours.
Linus Pauling met his wife in a home ec class that he taught the chemistry of cooking, and that was just that same thing, it seemed.
Cool.
Yeah, and
my favorite project was well, I had two actually. One was when I worked with the English and reading teachers, and we did a science fiction project where the kids would read a science fiction book and then they would have to write a short science fiction story, and then we just mixed it all together, or the reading teacher had her parts that she would grade, and English would of course would have their parts, and I would kind of critique their science and how they used it to make their story work. And the other project was we did a big field trip every year where we took the kids out and they would have to sit in, we took them to, this was in New York State, we took them to a county park, and then we'd have to sit in the woods park for a while and contemplate writing a poem. And then they would have to, we set out a grid where they would tally, the mathematics part, tally the creatures that happened to be in that grid work. And then we'd usually do my brain's going dead here, sorry. But we did a lot of stuff that each teacher had their own project at the park. And then the following week, we'd evaluate all those things and put them together. And so they could see that everything works together. There's nothing that's math assignment is not separate from your English literature. It just isn't. So
yeah,
that's what I did. And
yeah, that's awesome.
We usually work a lot. We met in teams, and so we did a lot of interdisciplinary work, and I think it made the experience that the kids had so much richer, that they weren't looking in separate little corners of their education, but it all meshed together.
Yeah, that's, I feel like, like what Steve was saying, the chemistry and cooking examples, and what you're saying, then, that, because somewhere, basically, I feel like, maybe I'm naive about this, but for most students, as soon as they see that it's all connected, then they're interested, right? So most of the people that come in, think they're not interested in chemistry or not interested in physics or whatever. It's because they have this idea in their mind that, physics is doing these worksheets with hard equations or something, right? Or chemistry is balancing.
Yeah, well, it's like math. The classic question about math when they start looking at something beyond arithmetic is, why do I have to learn how to solve an equation? And all you have to do is give them a practical example in their lives, if you can find one. Right. And if you've thought about it a little bit, and suddenly, even if it's basic math, well, have a checking account kind of thing, you know? Do you know how to balance it? Do you know how to calculate the interest you're going to get from the bank? And so any kind of scientific thinking can always be and should always be connected to a practical application as a way to get people interested. And then once you got them hooked, you can go wherever you want with it.
Right. Yeah, that's well said. Right. It's once you understand the problem and that it's relevant to you, then then you can make them want the solution rather than giving them the solution first, which is here's an equation that you have no idea where it came from.
Yeah,
Now
well,
learn it.
it's like when I talk to this group, I use words and I can't always remember. Like I was talking about, what was it the other day, allocentric. And I couldn't remember which was internal and external. And then I took 4 years of Latin in high school, and all of a sudden I had to think of, okay, what does allo mean as a prefix, and then it was clear. Then it was external, and there was no question in my mind. And so it's that kind of thing. It's finding ways to use the basic principles, regardless of what discipline that you've learned. And if you've really learned them, you can always fall back on them as a starting point to solving problems or remembering solutions to problems. And pointing that out, I found was a good way to, again, hook students. But it's the same idea. Here's a practical problem. Here are the principles behind thinking about, and actually, rather than listening to your neighbor's idea of what the solution should be, coming up with your own that's based on good, solid ideas and facts rather than somebody's opinion, which is the way most people think of solving problems. They ask their neighbors who know as little as they do about it.
Right. Or they ask Google or whatever.
Yeah, if they know how to ask the question.
If they know how to ask the right question, right? Yeah.
Right, and that's the other thing I liked about the way you were approaching it with your students. You're getting them to ask the question. And I think that again is an out of the box kind of thinking, because most of the time when I've gone into some place as a consultant, regardless of what the discipline was, it was usually they couldn't solve it themselves because they were asking the wrong question. They were.
Tim, I see you've turned your microphone on.
Oh, yeah.
What does that mean?
Oh, I don't know. Just to say thanks, Todd, for the talk. And, when you were talking about the feeling with the universe and the connectedness, and I feel like, I don't know if, when I've been out like in the Utah desert or something like that, where you're very, very, very far away from any light, and all you have is the light from the heavens above. And I feel really, really small and very insignificant. And then if you've ever had that where there's nothing in your peripheral vision, if you were to lie flat on your back and look up and all you see from your entire vision is the stars, you almost get like this stinging feeling in your stomach that you're going to fall off. And so those are some feelings I've had. And then a few years ago, I found myself in Carl Sagan's office at Caltech, working there in earth sciences, helping them set up an instrument that I designed. George Rossman is now in that office. So I had good fortune to be in there for about a week, setting that all up. But yeah, anyway, just to share my feelings, like that's kind of what I felt. And then I don't have a telescope, but I'm an optics guy, and I don't know where to start. My wife is saying, now, where are you going to put that? I know you want a telescope, but where are you going to put it? So it'd be nice if you have any recommendations, like for a website where you can get reviews and things like this that, or a good starter telescope.
Yeah, absolutely. I mean, it depends a lot on what you want. So first of all, thanks for that. That example reminded me of, just I can, if you've never done this before, just that feeling of almost getting yourself in that space where you feel like you're stuck to the earth, and the earth is keeping you, like a refrigerator magnet or something. It's keeping you from falling. It's a really profound feeling. If you've never, I'm feeling that again now that you've said that. So that's
it's weird.
Depending on what you want to look at, I mean, just my personal experience is that I would recommend getting something fairly small, just because then it's portable and you can easily take it out and use it whenever the old saying of, the telescope that you use is the one that's worth having, right? As opposed to you can have something fancy that's big and hard to manage, right? I can send you binoculars. Actually, I agree, Lou. Binoculars are a good thing to start with. There are some good, I can send out some websites that have like just sort of reviews of different starter telescopes. The one that comes to mind that ironically I have never had myself, but Celestron makes a little, I think it's like a 5 or 6 inch. Steve's nodding, maybe even know. Is it like Nexstar's SE or CE or something like that? There's a little portable.
If it's been a while since I've looked, but I started out with a small Celestron, and the good thing about them is you can use them as a spotting scope, so that you can do everything from bird watching to looking at the stars, depending on what you're interested in. And they're very portable and pretty much indestructible, although I eventually got sand in mine, which was not a good thing. And then I think Nexstar is actually a slightly different brand, but the same design concept, but I don't remember for sure.
Okay.
And then I'm trying to remember, I had, I think it was maybe a 6-inch reflecting telescope, which had a little bit more utility for looking further than the Celestron could do. And then I gave up because I never could figure out how to find the right star, even with a computer attached to the damn thing.
Yeah, and it's interesting because the current, because this is still sort of new, and they're still fairly expensive. I think probably $2,500 or something like that, but they're certainly talking about getting lower priced ones soon. But these EV scopes that Unistellar makes, that's what's impressed me about it, is that you literally just level the telescope. It has pattern recognition, that you just point it somewhere in the sky, it figures out where it is.
Wow.
And then it'll find, and then you use the little app and it'll find whatever you want to find pretty reliably. And some of the Celestron ones do that pretty well, but there's an alignment process that you have to go through first.
Yeah.
So yeah, depending on at what level of beginner scope or starter scope you want, I agree with Lou that I would actually say binoculars, good quality astronomical binoculars that you can get for what, maybe $100, $150, something like that for a new set, maybe. I don't know, maybe even less, depending on or probably because you have a wide field of view, it's easy to find things. You can actually see a lot more than you can with just your unaided eye, and it kind of gets you used to finding your way around the sky, and then you can sort of tell, like, do you really want to invest more in an actual telescope?
Yeah, good 40 power Zeisses are a great place to start, because they've got all sorts of corrections for everything, and they're actually very sophisticated, and they don't really cost that much, certainly under 200, although I haven't priced them lately.
Do those have an anti-vibration kind of thing, and do they track the sky?
Binoculars?
Well, whichever one you're talking about.
Well, I mean, I was gonna flip it around, and the other thing you can do is get a good high-powered telescopic lens for a good digital camera, And
Yep.
those do have image stabilization and all sorts of things. And with a good viewfinder on the back, a good digital one, you can do a pretty good job of finding things with those. And you can get what, 200 power out of some of the really big ones. They get expensive, but they're easy to use.
And you can, there's an app that you can do on your cell phone, and you point it up to the sky and it tells you where you are. And that's pretty cool if you have light, clear sky.
Yes, right. So I'm just sort of Googling some telescopes here and then pasting
Thanks,
it in
Todd.
here if you want to.
Yeah, or the satellites by SpaceX, the Starlink thing.
Yes.
Is that a problem? Is that a problem, really, or what?
It actually, yeah, I've been seeing a lot of posts recently about people seriously, astronomers seriously worried about this. I mean, I've definitely, it is getting to the point where like you're taking pictures of things, and it's pretty likely that you'll end up with a streak from something in the photo because there's just so much stuff up there. Not just the Starlink, the internet ones, but other things too. But yeah, people are concerned about it, especially if it keeps expanding. You won't be able to do what you said of just lying there under the sky and seeing only the stars. There will always be something in the way. So I'm not sure what's going to happen with that, whether there's going to be some kind of control on that, or yeah, that's a good question.
What's the next big astronomical event?
The next big astronomical event, that's a good question. My brain is filled with when the next little exoplanet transit in, which probably doesn't count as a big astronomical event. Well, there are, I don't know if this is not that soon, but 2024, there's going to be another total solar eclipse visible from the continental US, like across, it goes through Texas and up. I won't go through Oregon, but and the totality will be longer than the one that we probably most of us saw. What was that, 2017? Is that already been 3 years?
Yeah.
4 years? That's scary to think that that's been. I was going to say that just happened, and it's what else is, well, all the stuff on. Oh, it's called Night. Yes, good point. That is a good, important astronomical event. Of course, all the stuff. It's the lander on Mars, and I haven't followed the last few days. Does anybody know if the helicopter, the drone sort of thing that it was has flown yet, or
Yes,
I don't.
it did.
It did it? Okay.
I saw a little piece of it. I didn't see the whole report on the NewsHour a day or so ago.
Okay, so that's exciting from my point of view, because I missed it. So that's a good question to ponder. Actually, that's the next important. Yeah.
I know, Barbara, you were going to say something. I'm sorry. We started at the same moment.
Oh, that's okay. I was just going to say thanks ever so much. I'm sorry I was late and now I've got to leave early, but
That's okay. Nice to see
it
you.
was really interesting. Thank you so much.
Thanks, Barbara.
Barbara's the one
Bye-bye.
person actually teaching right now, right?
Yep. And tomorrow's our first day back at school. So,
Oh, right. That's
Oh
exciting.
my gosh.
yeah.
Good
Good
luck.
luck. Good luck. Yeah, I hope it goes well.
Bye-bye.
Bye.
Dave,
Right. So you're heading out, Steve? Or are you saying goodbye to her? Steve Van Veet.
that was the black thing that was in front of my screen. That's my new cat. It's gone now.
Transiting across your sky.
Transiting, right, exactly. You're demonstrating a transit.
My screen, yeah.
If
Big
I
black
could
Yeah.
ball.
hold up a light meter and figure out how much your screen has dimmed, and then we could figure out the the composition of your cat from that. Maybe.
Uh,
I'm curious, what, I can't remember who, Steve, was it Steve? Somebody said that the feeling you have of lying on the ground and looking up at the sky, this feeling of awe and how small we are and we're stuck to the earth. Do you think that education in astronomy empowers you to feel that even more strongly, even though you're not quite as virgin as you are when you just look up, as a child, but you actually know something? Does that empower you to have more of a connection to the universe, do you think? And is that, I don't know how to say that, but
Yeah, no, that's a good question. I mean, I certainly think so. I mean, that, my data point of me, and I guess my students that have talked about it, just like as an example, I feel like, knowing something about, so like last night we were looking at galaxies. There's one of my favorites, it's called the Whirlpool Galaxy, that M51, and it's about 30 or so million light years away. And when you look at a picture, here's a picture we took. This is not last night's, but similar. When you look at a picture of it, it's, there we go. It actually looks like a whirlpool. And this is a picture that we took just from campus, right? Just the other night. But then, and that's nice, it's pretty, right? It's a nice picture of a whirlpool. But then when you understand what a galaxy is, and you know that that's about 30 some million light years away, and you have the story about how long it's taken for light to get here, and then you can start people thinking about, okay, well, what was happening on Earth 30 million years ago? And what are they seeing? Like, you know what I mean? Like, it feels to me like that definitely enriches the sense of, it's one thing to know that the universe is big and I'm lying out under the stars and I feel small, and that's a powerful feeling too. But if you can really internalize the reality that spot in the sky that you're looking up at, you're seeing light that's been traveling for 30 million years. Now I'm not sure what I feel anymore even, right? I feel small and connected, and I don't know what, but I mean, so I would definitely say yes. And I would say that the students that I've worked with who have really gotten interested in this, that actually becomes part of their worldview or their practice of how they interact with the world or whatever. Like one of my most industrious, I guess I would say, one of the students that's really got most involved in this, who wasn't even a physics or astronomy major, he was a math major that just kind of got, didn't know anything about astronomy, but just got interested in it. He will sometimes ask if we can go take data, just because he's got something going on in his life that he just wants to process. And he just wants, he doesn't really care that much in that moment about collecting the data. I mean, he sort of does, but mostly he just wants to think about, he just wants to be in that space.
yeah.
And that feels like, that's what I was hoping for, kind of, right? Is to create that sort of thing. So I think, I mean, that's sort of anecdotal evidence, but I do think that it does make a real, there's something different when you know more than when it's just the feeling. Although, yeah,
It's just profound that something like that can be personal. You can have a personal relationship. I mean, actually incorporate it into who you are and your worldview. I think you're doing a fantastic job as a teacher if you're getting students to feel that at this point in their life. That's wonderful.
Well, thanks. Yeah, and mostly it's because it's been, for me, it's my whole, like, it's very personal for me, right? It's sort of like it's my sense of how this all can mean. And I don't even know how to, like, I do feel small. Like, I resonate with what you all are saying about making me feel small, but I also don't feel, I know is it is it Rumi? There's a quote that's something like, you are not a drop in the ocean, you're the entire ocean in a drop. That I think that's sort of how I feel when I look at stuff like this, right? Is that like, I do feel like, oh my gosh, how can I possibly be anything when that's 30 million light years away? And there's—
Can I respond to some of this, please?
Absolutely, please do.
This is Francher. Todd, I watched your TED talk about an hour before this presentation, and you almost brought me to tears. You ask us to close our eyes, you ask the audience then to close their eyes and to experience being.
Mm-hmm.
And I kind of thought this is where we go tonight, but we didn't. So let
Right.
me push it in that direction.
Sure, yeah, absolutely.
The first thing that I had to learn was that everything's in my head. You know, Tim talked about being alone in the desert and feeling small. Contrary to that, you are everything. Everything is in your head. And picking up on Steve's talks about perception, our own perception, the mechanics of perception the last few weeks, has got me thinking about how far we are from objective reality. Just the act of hearing, the sound waves have to go into the ear and activate the flexible drum, eardrum. Then the impulse is transferred to the anvil thing, the bone, which is that sound is then transferred to the cochlea, which goes to a liquid, which then creates an electronic impulse, which finally is perceived as sound in the back of your head. My God, that's 5 steps from the act. It's 5 steps from reality. So once we remember that, or we discover and internalize that everything, absolutely everything is in your head, you can never be alone again.
That's a good point.
Everything is in your head.
That's why I call Wanderer's topics from consciousness to cosmos. And it used to be from, well, I did it from cosmos to consciousness, and I was thinking which one's bigger. The consciousness is
look out
bigger.
look out at the night sky.
Yeah,
You're actually looking in that far.
right.
You know.
And that's some real old light there.
In addition to that, the entire universe is in your head, and each one of us is a separate universe, looking at the universe through the matrix of our life experience. It's a wonder we can even communicate. You know, I often buy books because of the title, which is, some of them are so powerful. I remember Jean Piaget's book entitled The Construction of Reality in the Child. You know, the reality we experience is a construct that we have made over our lifetimes. I have a book in front of me that I purchased years ago just because of the last sentence in the book. And it happens to be a book on astronomy, Principles of Astronomy, published in 1954. Now imagine a person studying astronomy for their entire college curriculum and coming to this last sentence. The central place of rest in the universe is everywhere and nowhere. Now that's powerful. Or completely destructive, I don't know.
The central place, I want to remember that phrase. The central, or say, can you say it one more time?
The central place of rest. I've read it so many times. The central place of rest in the universe is everywhere and nowhere.
Yes, I love that.
So each one of us is the exact center of the universe. The only experience we'll ever have is of from the exact center of the universe, as is every creature. He reaches out to his field of perception.
Yeah.
Okay.
That's beautiful.
So I guess I'm done for tonight.
I think that's
what more can be said than that, right?
Yeah, that sounds like a good place to branch off from. And if you have to go, it's It's okay.
Let me take it a step further.
Okay.
Art, about 3 or 4 weeks ago, talked about surrounding yourself with images, with positive images. He used images from nature with the intent to, I guess, bring us out of the doldrums of coronavirus isolation. Well, I learned long ago to surround yourself with yourself, things that remind you. Shakespeare said to be or not to be, that is a question. We all want to be, but we forget how to be. In fact, the only way to be what you want to be is to be what you want to be. But we forget. So I've surrounded myself with objects to remind me of what I want to be. You'll see over my shoulder the periodic table of the elements, which reminds me of all that is made of combinations of those 92 regenerative elements. What you don't see is over my shoulder up here is the great electromagnetic spectrum, which reminds me that just because you can't see it doesn't mean it isn't there. I mean, there's this huge range of frequencies. We can only tune in to just a small amount. We have organs that perceive trillions of cycles per second. We have other organs that perceive hundreds of cycles per second. But there are all those other frequencies that we need devices with dials and just to perceive that they're there. But to experience them is impossible, just impossible. So we in fact, the only miracle we have is that of being. I once wrote a koan, K-O-A-N. I thought it was a koan, and then I was very disappointed when I found out that a koan was 17 syllables. I did mine in 7. It goes like this. God is. All there is God. That's 7 syllables.
Right.
And the laws of the universe are God's. I'm not a Bible thumper, but the laws of the universe are God's laws. There are no miracles. We just don't understand things that we don't understand. But I think the important thing for me to remember is it's all in my head. I'm absolutely alone. It's all a miracle. I'm the center of the universe. And I try to learn what interests me, just like Steve does. What interests him? When I was 10, I knew I wanted to be an architect and I wanted to be an organist. So when I retired, I started being an organist. And that's a trip, let me tell you. Okay.
Are there really laws?
Excuse me?
Are there laws? Are there universal laws? Or
I can't
is it
hear that.
just,
I'm sorry.
Are there universal laws? You said God's
There
laws.
are, if I had a mentor, it's Buckminster Fuller, and he talked about general principles. There are things that only exist, and they're throughout the universe. Sometimes, most of the time, they occur in pairs. They always and only coexist, like gravity and radiation. Up and down don't exist in the universe. They only work on the planet. In and out, inside and outside. Bucky would describe how something comes into being. You take a little bit of the universe and you form a skin, and you get an inside and an outside. You don't have anything until you have inside and outside. But it's all there. So when Moses asked God for his name, God said, "I am that I am." I believe he was saying, I am all that is and all that isn't yet. You just have to put a skin around it and you got something. Yeah.
I had an experience that I wanted to share. I think I had just broken up with my girlfriend, and I was feeling pretty low, and I rode my motorcycle down to the beach. And it was a beautiful, just a beautiful, really clear night, but it was really windy. And I ended up down on the beach, and you know how the sand, it makes those, it gets carved out facing the ocean, and I was laying against that bank, you know, underneath the grass, but I was looking up the sky. I guess I wasn't laying so far under the grass, but I was looking up the sky. It was just incredibly clear, and all the stars, you know, it was just one of those nights, and all by myself, and the wind was blowing, and I was thinking, and as I was looking up there, I felt that feeling of being small, you know, and being so small that I was being almost lost. You know, I was losing myself in this vast expanse, and you know, that I was nothing compared, you know, in this vast expanse, that my life was meaningless and less than a point. And I was just having this profound experience of being small. And then all of a sudden I realized that everybody's in the same situation, everybody who's alive, and that I'm a part of that, you know, and that everybody's a part of it. And I'm connected to I'm part of this thing that is the entire universe. And all of a sudden I was overcome by this feeling of connectedness with everything. And that's never left me. You know, it just went from one thing to the other thing. There's like two sides of a coin. And I just wanted to share that. It was a profound experience for me.
Yeah, thank you. That feels like, you know, that, because that's such a, just that, the two sides of that. I like the transition between it, because I think that is a lot of the experience, right? Is it's both there at the same time, kind of.
Yeah, at the same time. It's just how you look at it.
Yeah,
they're both true.
Yep.
So Fuller had a very interesting way of explaining our being, I guess. One of his little mind trips was to imagine your breakfast backwards. You're eating a bowl of Cheerios, and it comes out of your mouth, back into the bowl, back into the box, back into the cabinet, back into the car, back to the grocery store, back to the field, and pretty soon your breakfast is a couple of molecules coming over the Himalayas. And then you put it all together again, it comes back, and you play the film forward, and you're eating your breakfast. And a couple of weeks later, you go out and clip your fingernails, get your hair cut. That's just last month's breakfast.
And then you could take it even further, and at some point it's a supernova explosion, and you know, whatever that's sort of out. Yeah.
Another way
I will never think of breakfast the same way again.
Another way to think about this is that we are in fact eternal. The stuff of which I am made has always been here. I'm just in this form processing the environment. It's becoming me for these. You know, it's moving through me. I know Bucky had this statistic, and I don't remember what it was like 1,000 tons of air, water, and food he processed in his 85 years. That became him and went on. But the stuff of which I am made will always be here. And after I die, and by the way, the I that I am cannot die. It never lived, was never born. It's something in there. It's always going to be here. We are here for eternity. You're experiencing eternity now. Now think about this, because to you, it has always been now. To me, it is always now. We are timeless. What we experience is timeless. You know, it all happens out there. This thing is going to die. This thing is going to, it exists in time. This to me explains the big biblical reference to original sin and the wages of sin is death. That's always confused me until I realized that everything that comes into time dies. So the only sin is separation from God. The only sin. The sin is actually in being born. And you experience the other. And the first other that you experience is the mother. That just really blew my mind when I realized the connection between being born and sin being separation from God. The first separation from existence, from everything else, is birth.
And that would make it a sort of sacrifice. You're making a sacrifice in order to be the eyes of God or something.
We are witnesses. I believe that's our purpose.
Yeah.
We are witnesses. Let's hear it from Marvin Gaye and show me a witness.
David, if you're playing, you should put on your microphone so we can hear you.
You can't hear me?
No, David Prescott Thompson looked like he was playing the or the piano.
Well, I'm on. That's the best I can do.
Another thing,
Yeah.
Your mic's not on.
so Todd, another thing I think about with astronomy is our planet, and like, you know, long term, what happens to mankind here, and whether it's even possible for us to leave here to go be someplace else, because, you know, if we don't get taken out by an impactor or destroy ourselves, then eventually we're doomed anyway, because of the core will cool and we'll lose our magnetic field, and the sun will strip away our atmosphere and our water, and we just can't stay here, even if mankind lives that long. And then I start thinking about how far away things are, and then I'm thinking, well, how could we do that? Maybe we could develop, it would all have to be like computerized, like frozen embryos or something, and then spaceships going off into the destinations where they're more likely to be live, and the systems would have to decide whether or not to start the life forming process on board before entering into a possible place that could be habitable. I mean, and then you have the politics of all of the countries that would want to say, you know, what would be taught, and then everything would have to be taught by robots, right? So you know, because we just can't live that long to reach those places, and I don't think you'd think of having generation after generation born and dying in space to get there. You know, it's kind of a weird thing.
It is, and it comes down to those distances, like you're talking about, right? I mean, if assuming the speed of light really is a limit, then this is bringing to mind Freeman Dyson, who I think was one of the ICEP speakers a while back, has a cool paper on kind of the future of life in the universe, and, you know, sort of the question about, you know, looking to the really ultimate limits of could we come up with ways for the information that stores, you know, life to persist sort of indefinitely into the future of the universe? Is an interesting question.
Could it be possible that the Earth is that vehicle right now?
It could be.
Could it be possible that the Earth is the Ark of the Bible?
I suppose it's possible, sure.
Could it be possible that the Earth is the only known garden in the universe? And if I may quote Genesis, and the Lord God put the man in the garden to care for it and to keep it. Make a great t-shirt, don't you think?
It's possible, but it's also possible that it's not.
That's true. That's true. We may be the only life form in the universe or not. Either way, it's a miracle. Well, I don't believe in miracles. Either way, it's amazing.
It is. It is.
That's actually a good example of one of those questions that is it's just the experience that it feels like it matters, right? Just thinking about whether we're alone in the universe or not is profound, whatever way you answer it. Go ahead. Sorry, Larry.
There's also the, we're here, we have agency of a sort, and we do have a lot of time before our sun goes supernova or whatever happens. We may learn, and we're learning very quickly. We seem to have crossed a threshold where our brain is evolving quickly. We're learning about how we learn, all of these meta level capacities, I guess. I think that, we stand a good chance by the time, too much time goes by, we'll know a lot more about our condition, and we'll have a lot more control if we choose to take it over our condition. I'm very optimistic in the long run if we can just if we can get past the hurdles of today, that we could, potentially live forever as a species and collect up all of the other life forms on our planet and join in a sort of a communal experience where there's fairness and mutual learning and appreciation, that kind of stuff. I don't think there's anything that if we get over these technological hurdles of staying here, that we have, including impactors and our own, weapons of war and stupidity and fear, all that kind of stuff. If we can somehow get over that, get past that, our options are going to increase, over time exponentially. And, we don't really know what we are at this point. We're getting an inkling that we're something, that's interesting, and malleable. But
don't go away, guys. I want to go get a book and show you something I find terribly instructive. I'll be back in 30 seconds.
Yeah, in several hundred years from now, people will look back on and say, "Oh, they used to use this thing called a phone," and they would see each other in this application they called Zoom.
Yeah, I kind of share that feeling of optimism, I guess, right? I mean, it feels like if we can make it, we've got at least 4 billion years before the sun changes significantly and things like that. And you think about, if we can make it past this bottleneck, and it will be interesting to see what, even 100 years from now, right? What do we look back on and not believe that people. Go ahead.
Oh.
Go ahead, Lynn. Sorry.
Sorry. I just remember Brian Greene saying that the sky, I don't remember how many thousand years, but if humans are still looking up at the sky, there won't be much to see because everything is moving far apart, and it will be pretty boring up there, which I can't quite imagine, but I don't remember. It's a long time before that's going to happen.
Yeah, and the nice
Do you
thing
have
is
any
that
idea about that, Todd?
yeah. So the nice thing is that at least our own galaxy will still be able to see the stars and so on. I think what he's talking about is that the galaxies will be, it'll be fine for most of us just lying back on the beach and looking up at the sky will still be good. But for astronomers, being able to see other galaxies, that's the problem, is that all of those will be so far away that we might not even know that, unless it's in the historical records, we might not even know that galaxies existed because everything will be so much farther apart, which would be an interesting, I don't know, be interesting to know how differently you would look at things if you didn't know that there were, if you thought it was just our little island and then empty space, how you would view things differently if that were the case.
In terms of how each of us live, I like that geological timeline
Yeah.
that shows us that our life is just this tiny dot, you know, and we don't know when the earthquake's going to happen. We don't really, maybe 400 million years till whatever, but we've just got this little dot. And I like the Thich Nhat Hanh, the kind of the Buddhist mentality to live your life purposefully, live it. When you're washing dishes, don't be distracted by the news. Wash that dish with purpose. I mean, it really feels good to live like that and not get distracted and carried away. And then apply your brain, you know, learn this stuff, but don't forget that little dot. That's all we've got.
So, did you find your book?
I did. I hope you can see this. Oh, it's upside down
No, it's not.
and backwards.
No, well, that's
No,
to you it is.
yeah, no, actually, we can see it.
Okay.
Can you hold it a little farther?
Revelation, revelation or revolution?
This is the secret book of Revelation.
Bring it back a little bit.
Pull
from
it
your
back
camera.
away from the camera a little bit so we can see
Okay,
the whole
it's getting
thing.
better.
There,
Yeah.
there you go. That's
Yeah.
good.
Okay. Well, the important thing is the woman, and the text is, I'll try to quote, I may not be able to, but it's, behold, there appeared in heaven a great wonder, a woman clothed with the sun, crowned with the stars, and the moon at her feet. This has to be the earth. It just has to be the earth.
Okay.
And if you read the ancient text with that kind of thinking, they come alive. They just become something other than mysterious writings. You know, the mystery goes out of it. You really see the science in it, so to speak.
Right.
So,
Well,
whoa,
I think
shut things
we're
down.
about to wrap. So thank you very much, Todd.
Yeah,
and
thanks for the
everybody
conversation.
that's
Thanks,
still
everybody.
hanging on here. And I like things that have been said. It's makes me feel that way too. You know humans are pretty smart sometimes, and you'd think we'd be able to get through what we're to treat each other better and treat the world and the earth appropriately and stuff, and we
Yeah,
got to do that.
Thank you. May I make a personal statement to David? Thank you for pushing me toward playing by ear.
Yeah. Well, have fun. Yeah.
Thank you.
And be safe, and all got your shots.
Thank you, Todd.
Yeah, yeah, thanks, Spencer. Nice.
Thank you very much.
Yeah, thank you all. That was fun. And you
Talk to you, Larry.
Next Tuesday, I will be fully vaccinated.
excellent.
Thank you so much, Todd. For
Yeah, thanks, Lynn. Thanks for the invitation.
And-
It's fun conversation. So,
Join us anytime.
okay, it's always the
Please.
same Zoom link, right? So,
We're holding it there for now. Yeah.
okay. I will see you again. Then.
Yeah. Great.
Thanks,
Thank
John.
you.
Thanks, everybody. Thanks,
Bye-bye.
Larry and David and Lynn.
I'm gonna turn the recording off.